Question 1G is a power triangle problem, and partial information is given about what are the sides of the triangle, and we have to find the missing side. So what we're supposed to do is sketch the power triangle and determine the reactive power when we're given the apparent power of 20 VA and a power factor of 0.5 leading. So to be able to solve this, we have to make sure we know what power factor is. So power factor is, so let's just say power factor PF is equal to cos theta, and where theta is the power angle and theta, the power angle, is equal to the phase of the voltage waveform minus the phase of the current waveform. So then what does leading power factor mean? Now, well, what's the point of knowing whether power factor is leading or lagging? It's because cosine is an even function, so we don't know whether the angle theta is actually positive or negative, and that's what the information leading or lagging gives us. So leading power factor means the current leads the voltage. So theta I is going to be greater than theta V, okay, because current is leading. Then that means that theta is less than 0. So theta is negative when we have a leading power factor. And where the term leading power factor comes from is, what does current do with respect to the voltage? So current leads the voltage, so those are linked. Okay, that's how we have leading, the term leading. Okay, and then we have, when we're lagging PF means the current lags the voltage. So that means the phase angle of the current is less than the phase angle of the voltage, because the current is lagging. Then theta is greater than 0. Okay, theta is positive. Okay, and again, the lagging refers to what the current does with respect to the voltage. The current lags the voltage. Okay, that's where those terms come from. Okay, in our case, we are leading by power factor 0.5. So theta is going to be negative. Okay, so what do we know? We know the power factor, we were given 0.5 leading, and that's equal to cos theta. So to find theta, we have to take the inverse cos, so cos minus 1 of 0.5 gives us 60 degrees. But we're going to convert that to minus 60 degrees because we're leading. Okay, so what does the power triangle look like? So we could even draw our axes, real and imaginary. And we can draw a triangle here. It's a right triangle, and we know that the phase angle is minus 60 degrees, and we were given an apparent power of 20 VA, so that's on the hypotenuse, so this side is the apparent power. So this is apparent power. Over here, just so that you know, this is P, and that's real power. And this side is Q, and that is the reactive power. And that is what we are supposed to find as an answer, what Q is. Okay, so that's the reactive power. And so just so we know, this is a right triangle. Okay, so we can just use trigonometry to find our answer. So we know that Q is going to be equal to 20, which is a hypotenuse, times the sine of minus 60 degrees, and that is going to work out to minus 17.321 vars. That's the units for reactive power. Okay, so then we just plug that in, minus 17.321.